Following our introduction, where we've seen some examples of alkanes and cycloalkanes, we're next going to look at alkane nomenclature, a systematic approach to naming. So our systematic approach to naming is called the IUPAC system, which stands for the International Union of Pure and Applied Chemistry. And there are a million rules for how to name organic compounds systematically. The basic system is that you are going to have a locant, followed by prefix, followed by parent, followed by suffix. Now, the suffix, this is what we had already mentioned. We would use ane to indicate that it's an alkane. The parent, this is what gives us information on how many carbons we're talking about. So this would be the meth, eth, etc. These are going to become obvious as we look at some examples. So to use the IUPAC approach, we are going to start with the longest chain and we are going to name it. Then we want to number the chain left to right, right to left, up to down, however it gives any substituents the lowest numbers possible. Then once we have identified our substituents or our branches, then we're going to name those branches as alkyl groups. We're going to list the alkyl groups alphabetically, so not by number, but alphabetically. And finally, for multiples, we'll use di, tri, tetra if we have multiples of the same substituent. But the di, tri, tetra doesn't count regarding the alphabetical listing. So I'm sure this is all crystal clear and you're ready to just jump in. What I want you to do is keep this list accessible and let's move on to some examples so that we can apply these rules. So let's look, for example, at the hexane isomers that we drew a couple slides ago. So here we have our straight chain, and we already mentioned that this could be named N-hexane. But this is the common name, not the IUPAC name. So that's very, very important to be able to separate those. You need to be able to recognize an N-alkane if that is used in the book, but I'm going to stick with IUPAC naming. So we will not name this compound N-hexane. Instead, it will just be hexane. Because our longest chain, 1, 2, 3, 4, 5, 6, we don't have any substituents, so we skip steps 2 and 3, and we skip 4 and 5 also. So this compound is called hexane. For the IUPAC name, we do not use the N. It is just hexane. All right, that one wasn't very fun. Let's look at the next one. Start with the longest chain. So here we have 1, 2, 3, 4, 5 carbons. So that would be pentane. If we number this molecule from left to right, this is 1, 2, 3, 4, 5. If we went right to left, 1, 2, 3, 4. We want to give our branch the lowest number possible, so we will go left to right. So this is 1, 2, 3, 4, and 5. Now we name our branch as an alkyl group substituent. This is a 1-carbon branch, so it will be called a methyl group. And then we need to list the alkyl groups alphabetically. That's easy since there's only one, but we have to include the locant telling us where it is. So at carbon 2, we have a methyl group on our pentane molecule. So this compound is called 2-methyl-pentane. So we put a hyphen in between our number and the words, but this is a single word where we list the substituent as a prefix. Here's the parent, and then here's the suffix. So 2-methyl-pentane. For the next one, our longest carbon chain is 5 carbons, so it has the base name of pentane. Our branch is a methyl group. And if we number left to right or right to left, either way, this is carbon 3. So this one would be 3-methyl pentane. Again, methylpentane is one word, no space in between. Okay, here's another one, and we have 1, 2, 3, 4, 5 carbons, pentane. And here is our methyl branch. If we number left to right, this would be carbon 4, but if we number right to left, this would be 1, 2, 3, 4, 5. So we want a number from right to left, which would give us 2-methyl pentane, which is the same as this compound here. So learning about nomenclature can be rather boring, but the nice thing about it is that it can help you to identify when you have two different representations of the exact same compound. So this is not an isomer, it was just a different representation. If we look at the next one, we have 1, 2, 3, 4 carbons. Any way we go, 4 carbons is the longest chain, so that would give us butane. We have a methyl group and another methyl group, so this would be a dimethyl, di for 2 methyl groups. And then if we number left to right, 1, 2, 3, 4. So our methyl groups are at carbon 2 and at carbon 3. So we put this together as 2, 3 dash dimethyl butane. The parent, the suffix, the prefix on the prefix, and the locant. For this one, 1, 2, 3, 4 carbons again, and we have 2 methyl groups. This time they're both on the same carbon, and we number from left to right to give this carbon number 2. So this would be 2, 2 dash dimethyl butane. Again, dimethylbutane is just one word. I ran out of space. We have to specify where our methyl groups are. Just saying 2-dimethyl, well, where's the other methyl? So we have to specify one methyl group is at carbon 2, and the other methyl group is also at carbon 2. So 2,2-dimethyl butane. So just by looking at the hexane isomers, we have applied 4 of the 5 rules for the systematic IUPAC naming. One other thing I want you to notice, I can talk about hexane as, I guess this would be like an adjective, hexane isomers. So here I'm talking about the group of compounds that are C6H14. Here, when I say hexane, now I am referring to this specific compound, and hexane is the IUPAC name. So just be careful that you are thinking about hexane as the IUPAC name for this compound versus hexane as more of a descriptor referring to the C6H14, referring to any or all of these compounds.
On to the next slide.
Now let's take a look at a few more examples. With this compound, we have 1, 2, 3, 4, 5, 6 carbons in our longest chain. So that would have the base name of hexane. We have a branch here, here, and here. So these are all methyl groups. So this would be a trimethyl. And then left to right, 1, 2, 3, 4, 5, 6. That would give us a branch at 2, 5, 5. Or we could number 1, 2, 3, 4, 5. And that way would give us branches at 2, 2, 5. So the green way gives us the lower numbers. When you're comparing different possibilities, you're looking for the first difference. So if this is 2, and then here we have 2 and 5, this is where we focus. So this compound is 2,2,5 dash trimethyl hexane. If we look at the compound below, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. So this is octane. So this has the base name octane. And then once again, we have 3 methyl branches. So trimethyl. Now let's do the same thing in terms of numbering. If we go left to right, we have 1, 2, 3, 4, 5, 6. So we would have 2, 6, 6. If we go right to left, 1, 2, 3, 4, 5, 6, 7. Here we have 3, 3, 7. We're not interested in looking at overall how much does it add up to. Instead, we're just looking for the first point of difference. Going the blue way, we start out with 2. Going the green way, we start out with 3. So we are going blue. So this is 2,6,6 trimethyl octane. 2,6,6 trimethyl octane. All right, let's come up to the top right. We have 1, 2, 3, 4, 5, 6 carbons, right? So this should be hexane. But remember, the first rule is to find the longest chain. It doesn't have to be the longest chain written from left to right. You have to find the longest chain. So the longest chain is actually this one. And this has 7 carbons, so it has the base name of heptane. Now we would number from right to left, which would give 1, 2, 3, and this is a methyl group, so this is 3-methyl heptane. 3-methyl heptane. And the last example on this page, we have 1, 2, 3, 4, 5, 6, 7 heptane. We have 2 methyl branches, so this would be dimethyl. Now we have 2 carbons. So remember, a 2-carbon alkane is ethane. So a 2-carbon alkyl group would be ethyl. If we number left to right, our first substituent is at carbon 2. If we number right to left, our first substituent would be at carbon 3. So we want to go left to right. So our dimethyl is at carbon 2, and our ethyl is at carbon 5. So now, how do we put it all together? Well, this is where the rule comes in about listing the alkyl groups alphabetically. Because we have different alkyl groups, we need to name the ethyl and the methyl. We ignore the di when it comes to alphabetizing. So this compound is going to be 5-ethyl dash 2,2-dimethyl heptane. 5-ethyl 2,2-dimethylheptane. And again, dimethylheptane is a single word. All right, now we're having some fun. In an earlier video, we drew all of the heptane isomers, but without looking at that, I want you to get more practice. So go ahead and draw all of the heptane isomers. Once you think you've got them all, then you can go back and look at slide 6 and make sure that you have them. Then I want you to get the practice naming all of those heptane isomers using IUPAC names. Practice is going to be very, very important. We need to talk about a few more alkyl substituents. If you have a 1-carbon branch, it's a methyl group. If you have a 2-carbon branch, it is an ethyl group. But once we get to a 3-carbon branch, those 3 carbons could be branched in a line, or they could be branched with a branch. So we need ways to be able to specify these different substituents. And so all of these compounds have the base name of decane. So they all have 10 carbons in the longest chain, so that then we're just going to focus on the substituent. So here, where we have our 3 carbons in a straight line, we name this as a propyl. So we would put this together as 1, 2, 3, 4, 5, 5 propyl decane. Now over here, We actually have two options for how to name this substituent. We can use a combination of common name and IUPAC. So remember that the iso is used when we have a methyl branch off of carbon 2. So we could think of it as it's as if here's our branch, and then this is carbon 2 branching off of the branch. And so this would be called an isopropyl group. So this compound can be named 5-isopropyl decane. Alternatively, we can go with a completely IUPAC name, and in that case, we would name this as an ethyl branch, and then here's carbon 1, carbon 2. Off of carbon 1, we have a methyl. So this is a 1-methyl ethyl as a branch. So at carbon 5, we have parentheses 1-methyl ethyl, close parentheses, that's the end of the name of the substituent, and it's off of carbon 5 of decane. So 5-1-methyl ethyl decane. You will see this used. I'm going to stick with the combination of the common name with the overall IUPAC system. The next few, we are looking at 4 carbons, 4 carbons, 4 carbons, and 4 carbons. So if we think about the common name, this would be an N-butyl group. This one is a tert-butyl, where this carbon in the branch itself, it's connected to 1, 2, 3 other carbons. So this is a tertiary. So it's a tert-butyl or T-butyl. This one is called sec-butyl because the carbon that meets the main chain is connected to 2 other carbons, so it's a secondary, so that would be sec-butyl. And this one would be called isobutyl because we have the methyl group off of the second carbon at the end. So this would be 5N-butyl decane. This one would be 5T-butyl decane, 5-sec-butyl decane, 5-isobutyl decane. If we go with the straight IUPAC, then this would just be 5-butyl decane, because remember the N goes with the common name. So then we wouldn't include the N if we were going completely IUPAC. So this would be 5-butyl decane. Okay, now this one. We would call this our ethyl branch, and then we have 2 methyls. So 1,1-dimethyl ethyl is the name of the branch. So the whole compound would be 5 dash parentheses 1 comma 1 dash dimethyl ethyl close parentheses decane. So this says we have a 10 carbon alkane. At position 5, we have a branch that is 2 carbons, and at the first carbon off the main chain, we have a methyl group and another methyl group. So the good news is that's a lot of information in that name. The bad news is that's really tedious. In the bottom left, if we went completely IUPAC, this would be a propyl chain, and there would be a methyl branch. So this would be a 1-methyl propyl substituent. And then over here, we would have 1, 2, 3. So this would be a propyl chain as well, but then we would have a methyl branch at carbon 2. So this is 2-methyl propyl as a substituent. And then we would have to say at position 5, of decane. We have a 1-methylpropyl group. So for many of these, the full IUPAC name can be rather cumbersome. So sometimes it is a lot easier to use the combination of the common name for the substituent, but still using the overall IUPAC system. Now, when it comes to these substituents, I like isopropyl, I like T-butyl. I am never going to use propyl or N-butyl or sec-butyl or isobutyl. And I'm not going to use the full IUPAC names either. So if you have a problem from the textbook, then you might have these branches. Well, then use the textbook as a reference. On worksheets, on quizzes, on exams, if I'm using these branches, then you are free to name them as isopropyl and T-butyl, and you do not have to use the full IUPAC approach. Okay, so after all that, what do you need to know? So I want you to know the common names for C1 to C5. I want you to know the IUPAC names for C1 to C10. So this means that our biggest base name would be decane, and I don't need you to know what is 12 carbons or what is 14 carbons. You would use the book as a resource for that. I want you to know some common substituents, and what I call common would be methyl, ethyl, isopropyl, and T-butyl. And I want you to know how to name. So focus on numbering, focus on using the di, tri, etc. Include the number, then the name, and list them alphabetically. Now you should use the textbook as a reference for the common names of the butyl substituents, the common names of other higher alkyl groups. So we can keep using sec and iso, but I'm not going to use those. If it comes up in a textbook problem, then use the textbook as a resource. And you can also use the textbook as a reference for the IUPAC names of the more complicated alkyl groups. So rather than using isopropyl, if you have the 1-methyl ethyl, rather than using T-butyl, you would use a textbook as a reference for 1,1-dimethyl ethyl. So this is just the starting point of learning about IUPAC naming. Throughout the year, we are going to add on rules for all the different families of organic compounds.